to you, boys and girls, my young Padawans. This is Mr. Brown coming to you from the Floyd Middle Magnet School digital online campus. Today, we are going to talk about the coordinate plane, a very important piece in some advanced mathematics you will get to in the upcoming years. But first, we are going to have a brief history lesson about a famous mathematician named Rene Descartes.
René Descartes was a famous French philosopher, scientist, and mathematician who lived from 1596 to 1650. The coordinate system we commonly use is also called the Cartesian system, named after him. Legend has it that one day Descartes saw a fly crawling across the ceiling above his bed. He began to think about how he might tell someone else where the fly was located on the ceiling. These thoughts led him to come up with the coordinate plane we use today. On a side note, René Descartes was often considered by women of his day to be an incredibly attractive man.
Sacre bleu! What did you say about my mother? I tell you what, I'm going to swat the fly. Wait a second. I wish there was a way I could tell the homies where on the roof the fly was located. Sacre bleu! What a foul-mouthed fly! I don't care about the mouth. I shall kill this fly. Come here!
There you go, boys and girls. That is exactly how it happened. I might have taken some liberties in the dialogue as it was not exactly recorded, but the legend is true, right? That Rene Descartes came up with the coordinate plane system that we use today. And it all centered around a little fly and one super bored man. All right, so let's get some definitions out of the way so that we can all use the same terminology moving forward. All right?
Today we are talking about the coordinate plane. All right, so if you're taking notes with me, let's get down the definition of a coordinate plane. A coordinate plane is a plane. Now we've talked about this in class before all of this craziness. A plane just means a flat surface. So a flat surface divided into 4 quadrants by a horizontal line and the horizontal line that we use is the x-axis. All right, divided into 4 quadrants by a horizontal line and a vertical line. All right, the vertical line is the y-axis. All right, so here is an example of a plane divided into 4 quadrants. If you are drawing a coordinate plane, there are a couple of important things to label. You may put numbers every so often, but that's not, that is important, but it's not the important part to label. Okay, we want to label the x-axis. The x-axis is the horizontal one, so just out here towards the end, we're going to put an x. All right, just a happy little x. all right? And then the vertical line is the y-axis, so somewhere up here towards the top, we're going to label this as y. All right? The other important thing to label is where everything starts from. That's right here in the middle. We put a little O, and that O is the origin. Okay, the origin is where you start. The origin is at 0, 0. All right? So, within this coordinate plane, we can have points. Okay, that's a point. All right, this is a point. Points are normally labeled with a capitalized letter. So we call this point A. We call this point B. Right? Now, if I need to tell you how to get to point A, we need a common language. All right, the language we use are coordinates, all right? There are two coordinates, the x coordinate and the y coordinate. The x coordinate tells you the number of horizontal units or spaces to move from the origin. So from left to right, right? If the x coordinate is positive, you're moving to the right. If the x coordinate is negative, you're moving to the left. All right, just like on a number line. All right, the y coordinate is the number of vertical units a point is from the origin. Vertical is up and down. All right, so if your y coordinate is positive, you're going up. If your y coordinate is negative, you're going down. All right, these two coordinates together make an ordered pair. All right, and they go in alphabetical order. First is the x coordinate. Second is the y coordinate. All right, so the first number tells you how much to move left or right. The second coordinate is the y coordinate. It tells you how much to move up and down. So if we come back up here to our first coordinate plane and we want to tell where A is at, all right, first you would tell which point you're talking about. You'd use an A. Then you put parentheses because your coordinates are within these parentheses. All right, we start from 0. First, we go horizontal, side to side. So I need to move 1, 2, 3, 4 places to the right to get to the A. So the first coordinate, the x coordinate, is 4. And then once I'm there, do I go up or do I go down? I go up. How many spaces? 1, 2, 3. So A is located at 4, 3. All right, let's do B. Where is B? Again, you go back to the origin, 0, 0. This time to get to B, we have to move to the left. We move 1 place to the left. Well, moving to the left is negative 1. And then to get to B from here, do we go up or do we go down? We go down. How many spaces? 1, 2, 3. So negative 1, negative 3 are the coordinates for the point B. All right, so write the coordinates of each point. I have given us a coordinate plane, and I've put some points around this plane. And let's find each one. The first one we want to do is A. All right, so we're going to label it A. All right, we started the origin. Do we go to the right or to the left? We go to the left. How many spaces? 1, 2. So left 2 spaces would be negative 2. And then up 1, 2, 3, 4, 5. So A is located at negative 2, 5. What if I accidentally got those backwards and said that A was located at 5, negative 2? Well, that would mean that A was right here. Is this where A is? No, no, it's not. All right, how could you think that? No, it's up there. See, I see it. All right, it's important to get these in the correct order. Otherwise, like let's say these were instructions to get to the grocery store, and I told you the instructions backwards. Well, then you wind up over here in a shady part of town that's not safe, okay, when you should be over here at Walmart picking up some bologna. Okay, let's look at B. All right, start at 0, 0. We move to the right 2. So B is at 2. And then we go down 1, 2, 3. So 2, negative 3. All right, think real fast. Look and see where point C is. You got it? All right. So C is at negative 1, 2, 3, 4, 5, negative 5. And then negative 1, 2, 3, 4, negative 4. All right, figure out D real fast. Now D is on the y-axis. All right, so if we start at the origin, do we actually need to go to the left or to the right to get to D? We don't. We're already in line with it. So for D, the x-coordinate is 0. Now the y-coordinate is negative 1, 2, 3, 4, 5, so negative 5. But notice that the x-coordinate was 0 because we don't need to move along the x-axis. All right, E. Well, to get from the origin to E, we need to move to the right 1, 2, 3, 4, 5, 6 spaces. All right, and then how far do we have to move up or down? Well, we're already there. So the y-coordinate, we don't need to move vertically. We're already there. All right, now, like the story said Rene Descartes did earlier, let's find the location of this fly. All right, we start at the origin. We move to the right 1, 2, 3 spaces. So the fly is at 3. And then we move up 1, 2. The fly is at 3, 2. All right, and then where did we say the origin was? The origin is located at 0, 0. Got it? Good. The x and y axis divide the coordinate plane into 4 quadrants. Okay, and one of the other things we need to know how to do is to tell what quadrant a point is located. All right, the quadrants use Roman numerals, and they start with where the x and y coordinates are both positive. That would be this one right here. So this is quadrant 1. And then they go counterclockwise. All right, backwards from how a clock goes. You know, the clock goes beep, 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 beep. Counterclockwise means backwards from the way a clock goes. So if this is quadrant 1, where the x's are positive and the y's are positive, where the x's are negative and the y's are positive, this is quadrant 2. This is quadrant 3. That's where the x's and the y's are both negative. And then this is quadrant 4. IB is a 4 in Roman numerals. It's where the x's are positive but the y's are negative. So I'm going to plot a couple of points and let's write what quadrant that point is in. So, boom, let's call this A. What quadrant is A located in? It is in quadrant 1. All right, what about B? Well, B is in quadrant 3. All right, what if I put a point way up here and called this C? All right, Mr. Brown, that's not. Okay, but these arrows mean that these lines, even though you don't see them, extend forever. So what quadrant is this up here where the C is? C is in quadrant 2, okay? The idea that these continue on forever need to be in your brain too. All right, lastly, what if a point is on one of the axes, okay? What quadrant is point D in? All right, well, a point is infinitesimally, I believe that's the word, small, right? So it doesn't, I know our little picture shows that it kind of hangs over in both, but you can't do that as a point. So if I asked you what quadrant is point D, you would say that it is not in a quadrant. If you wanted to be even more specific, you could add that it is on the x-axis. Okay, but if it's on the x-axis or on the y-axis, it's technically not in a quadrant. Next little section, I would like you to pause the video, draw a coordinate plane on your own graph paper that you should have, and graph these 5 points and tell me what quadrant each of those points is located in. Please pause the video and do that on your own paper.
Don't cheat.
Did you do it? Good. All right, so I'm going to quickly graph these 5 points on my coordinate plane, and then we'll come back and we'll talk about what quadrant those points are in. So F is at 3, 5. G is at -2, 4. H is at 1, -5. I is at -4, 1. And J is at 5, 0. Hopefully those are where your points wound up as well. All right, so that was the first part of the instructions. Graph each point on the coordinate plane. Now, we want to, for each one of these 5 points, tell what quadrant that point is in. Remember, this is quadrant 1, and then they go counterclockwise. So this is 2, 3, 4. All right, so point F is in quadrant number 1. G is in quadrant 2. H down here is in quadrant 4. I is at -4, 1. So I is in quadrant 2. And then what about J? All right, remember, if it's on the X or Y axis, you write not in a quadrant. And if you want to be specific, it is on the X axis. Hopefully you got all of those right. All right, I need to be able to give you 2 points in a plane, and you tell me if the line that contains those 2 points is a horizontal or a vertical line. All right, let me show you what I'm talking about. All right, the first 2 points that we have are A and B. A is at -33 and B is at -3, -2. And I want to know, if I drew a line through those 2 points, would that line be parallel to the x-axis? Would it be horizontal? Or would it be parallel to the y-axis? Would it be a vertical line? All right, so to do this, we are going to graph these 2 points, and then use a ruler to draw a nice straight line through those 2 points and tell if that's a horizontal line or a vertical line. All right, so A is at -3, 3, and we're going to label it A. And B is at -3, -2. We're going to label that point. Then we're going to take a ruler so that our line is nice and straight, and we're going to draw a line through those 2 points. All right? So now that we've drawn a line through those 2 points, were those points on a horizontal line or a vertical? Remember, horizontal means side to side, like the horizon at a beach. All right, vertical is up and down. When in basketball, your vertical leap is how high you can jump up in the air. All right, so these 2 points, which made up line AB, is a vertical line. All right? Let's do a different one. C is at 3, 2. So 3, 2. This is C. D is at -1, 2. D. And we take our ruler and we draw a line through these points. Ow, just stabbed myself with this pen. All right, don't do that, kids. Don't try that at home. All right, so line CD is a, all right, what kind of line is that? A horizontal line. Okay? All right, now that we've done that, I need us to make an observation. Look at the ones that were on a vertical line. Which coordinate was the same in both the points A and B? All right, which coordinate? The X coordinates were the same or the Y coordinates were the same? The X's were the same. They were both -3. So on a horizontal line, the points are going to have the same, all right? So on a horizontal line, oops, that's that one. All right, that was a vertical line. Let's start with that one. On a vertical line, excuse me, they are going to have the same X coordinate. All right, now the second one that was a horizontal line, which coordinate was the same? It was the Y coordinate. Both of these had a 2 for their Y coordinate. So if the points are on a horizontal line, they will have the same Y coordinate. Now, why is this helpful? Well, we need to be able to tell if it's a horizontal line or a vertical line just by looking at the coordinates. All right, so look at, where is it? Found it. All right, we want to tell if the line that passes through these 2 pairs of points is vertical, horizontal, or neither. All right, so we're going to look at the 2 coordinates and see which of, we're going to look at the 2 ordered pairs and see which coordinate is the same. In this first one, 6, -3, and -7, -3, the Y coordinate is the same. Well, as we said just a second ago, if the Y coordinate is the same, then the line that passes through those 2 is a horizontal line. Okay? Look at these next 2, 8, 2, and 8, -20. All right, if we wanted to graph that, we would need a big coordinate plane to get all the way to -20. Or I could remember that if the X coordinate is the same, then the line that passes through them is a vertical line. All right, last one. 8, 4, and negative 7, negative 4. Well, which coordinate is the same? 8 and negative 7? Or 4 and negative 4? Neither one is the same. So this line right here is going to be neither horizontal nor vertical. All right, it would do something like this. Instead of going straight up and down or straight side to side, it would be at a slant, all right, which would give us a neither.
I've got for you today. Now, I know that most of this was a review for you guys. Hopefully you learned something new, something that you can carry forward. Here is the plan for the rest of the week. Tuesday, tomorrow, you are going to have a practice sheet. You are either going to need to print it out or work these problems on your own sheet of graph paper, okay? But tomorrow we're going to have a review on the coordinate plane. Wednesday, we're going to have a brand new video on slopes and rates of change, again, using the coordinate plane. Thursday, we are going to review slopes and rates of change. And then Friday, we are going to have our 4th minor grade of the 4th 9 weeks over the topics of the coordinate plane and slopes and rates of change. So don't forget to like, comment, and subscribe to Mr. Brown's YouTube channel. Ring that bell, bing, 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 ding, so that you know every time I drop a video here on my channel, so that you'll be up to date and smarter every single time. All right, don't forget to be safe and don't do drugs.